Okay, hey everybody. So I'm Nico, I'm part of the Flux team, and today we're gonna be talking about fields and ground fields in particular. So the agenda for today is roughly gonna look like this. So we're gonna do a quick introduction to what Flux is, and then we're gonna be moving forward discussing what ground fields are from an electronics perspective or just engineering perspective, and then we're gonna talk about a little bit of actually Flux. Brooks, our lead designer, is gonna talk about sort of Flux design philosophy and how did we and why did we implement ground fields the way we did. So what is the problem that we see with fields today, and how and which solution we came up with. And then we're gonna do a live demo showing you guys like ground fields in Flux live. So how do you configure them, add them, remove them, and all the different options that you have around them. And then we're gonna have a Q&A session. So it's at least gonna be 15 minutes. We can extend a little bit depending on the questions. And the Q&A session is usually wide in terms of what can be asked. Today, it's actually pretty great because we have PCB experts, we have a lead designer, we have developers, like actually the developer who coded ground field. So we can probably answer any question that that might come up. All right, so most of you already know what Flux is. I'm going to try and do this a little bit quickly. So Flux is a browser-based electronic design tool, or EDA. It's 2+ years in the making, and it has a few things are different that Flux enables that some other tools don't, which is an integrated workflow, which means that you can do everything within the same tool. So from schematic, simulation, specifically PCB layout, part sourcing, pricing. So everything is in your web, and everything is synchronized immediately. And then it's built around collaboration. So not necessarily more than one engineer designing at the same time, but collaboration in terms of different disciplines or different stakeholders. You can think about like product managers or sourcers or mechanical engineers, PCB designers, and you also have like version control built in. And then reusable, which means that we build everything so that people can build blocks that they can reuse in other designs, blocks that they made themselves or blocks that somebody else made. So it enables collaboration in that sense as well. So not only you can reuse the blocks that you've made or design that you've made, but also can reuse designs and blocks that somebody else made. So all these modules can be nested. So you can have a part, this is actually a sub-module. So it's a full-blown small design or small snippet of a design that you can reuse in multiple designs. After the call, I'm going to send you guys links to different talks where we covered all these different aspects in documentation. So if you want to dig deeper, we have videos and docs for pretty much all of this. And then we have rules. So they're kind of similar to what design rule checks or DRCs are in traditional tools, but right. But they also affect the design in real time. So you can change the properties of different components or parts in real time using rules. And then simulation is always on. So you don't need to, again, you need to switch to any other tools. You need to enable or disable it. It's always running. It's always telling you what you need to know. So let's talk a little bit about copper fields or ground fields. Note the matching hat from Flux, from Brooks and slide. Nice touch. So what's a ground field? So a field in general is filling empty space or space that does not covered by other traces with copper. Ground fields which is gonna be talking about today, is specifically ground connected copper field. So you fill your board with copper that is connected to ground. So in this case, on the left, you can see a standard PCB design that doesn't have ground field. So you can see all that black space or empty space, which is going to have nothing in the final manufactured PCB. And on the right, you see that all that empty space is covered by copper, the red that identifies the top layer of the PCB. And you also notice that it has a range of vias in a regular pattern. That's called via stitching. So basically, it connects the different ground planes in different layers together, so that there's kind of like a one continuous of some sort, continuous connection to ground. So the first question is like, why would you want ground field in your design? So there's three main aspects. The first two, which is signal integrity and power distribution, kind of have to do with the same concept, which is the return path. So we all know that in order for a circuit to actually be a circuit, it needs to be a loop, right? So you need to have a source that goes to a sink or a target and then back. So if you don't have this loop, there's no circuit. So the return path is the return part of that loop. I'm also going to link a specific talk that Kerry gave around. I call these different topics. So if you're more interested on the sort of electronics engineering perspective, we'll cover that in full there. I'm going to give a quick overview so that we can sort of set the stage for how and why we implemented ground fields the way we did. So in terms of signal integrity in the most basic sense is that two traces that carry a specific signal do not interfere with each other, and the integrity of that signal that is running is preserved. So if there's no reference plane in this case, so as I was saying, so the trace, which is the sort of the orange part on top, and the reference plane, which is the return path, you can see that here the electric and magnetic fields are represented by these arrows and blue and sort of reddish. So we need that return path. So depending on how that return path is laid out, it's going to have a huge impact on our large track circuit. So in the case of signal integrity, if you had another trace right next to the trace that is shown here, the orange one, you can see that the electrics and magnetic fields potentially will collide with the trace that's next to it. If we remove the reference plane, in this case, the ground plane, what happens is that all these electric and magnetic field doesn't have a place to end. So more of that is going to be affecting the trace next to it. So basically affecting signal integrity. That's why in most cases for improving signal integrity, you need a solid reference plane. And in most cases that reference plane is ground. Hence why we're talking about ground fields today. And then the second one is a cleaner power distribution, in the sense that with the same concept, you need a return path, and the current that goes from one path returns from the return path. Like current has to go fully around the loop. In this case, what we see is a PCB that has a very narrow path around where it's actually zoomed in. So in that actual small path, all the current concentrates, and that makes it hot because there's more power going through less of a surface. So if we had a proper ground plane in this case, basically that covers the whole area, which is what you see on the blue ground on the left of the image. You can see that it's like all the current is evenly distributed, so it doesn't create these like sort of bottlenecks. So having a proper big return path makes for a cleaner power distribution. We dig a lot deeper into all of these concepts in the video that I'm going to link afterwards, which is kind of like a general guideline, so we understand what's coming next. So just to recap, in terms of signal integrity and power distribution, so basically what we're targeting here is the return path, which is sometimes kind of not taken care of properly. So which is why having a proper ground is important. And again, if the return path is either too small for the current that you need to take, or it's not properly laid out, you can either have signal integrity problems or power distribution problems. And then there's a whole kind of other topic around improved PCB fabrication. So you know, or some of you might know, that a PCB is basically a layer or sandwich of copper and then some sort of epoxy, and then copper, and then epoxy and copper. This epoxy and copper, when they get hot, they have different properties. So one of them expands a lot more than the other, right? So in a modern PCB fabrication process, what happens is that PCB is made, and then eventually all the components are soldered onto it. And in that process of soldering, the whole PCB gets hot, so that actually solder melts. And then what happens is, if you have different different materials that deform or get hot and expand at different rates and shapes, if for example, if you have copper that is not properly distributed or evenly distributed, you will see that the PCB will warp or will bend in some sort of way. So how ground fields or any copper field in general, but in this case ground field, how it helps, it makes the distribution of copper even everywhere in every layer. So when everything gets hot and then cold back again, everything expands and shrinks in the same proportion, so the PCB stays as flat as possible. And then the other part is on the sort of the etching process. So in order for the PCB to be created, basically you have at the beginning of the process, which is a solid layer of copper, and then the epoxy of the laminate, and then some of that copper is etched away. So if you have a lot of empty space, it means that you need to etch a lot of copper, and that takes more time, and at high volumes that usually ends up costing more. So just to recap a little bit before I move forward with Brooks. So ground fields, so there's two general aspects in which they help. So we have signal integrity and cleaner power distribution, which is affected by the way ground fields improve the return path. And then PCB fabrication, we have the warping of PCBs and the etching process, and the way it helps is by basically making the amount of copper even in every layer. So that's the EE part of copper fields. We're not going to be talking about sort of the more practical or the way we design copper fields.
Yeah, dude. Hey, how about you stop presenting and I'll just
all right
here.
Let's do it.
Oh no, you're giving away the slides. Everyone's gonna know.
Oh no.
What my bullets are. Okay, thanks, Nico. Hi, everybody. My name is Brooks Solvig. I'm a product designer here at Flux. I've been here for the last almost 2 years. Whoa, nearly. And it's been my pleasure to work on copper fills. It's a big, meaty problem. But it's been really interesting. It's very interesting to approach this in a different way. Thanks, Carrie, for the comment. Yeah, I own a dog and I like dogs. So I'm going to share the presentation. I kind of want to talk through a little bit about like our design philosophy. I have 20 minutes on the clock for this, but it's not going to take 20. I want to get us to the demo, and then you're going to ask lots of questions and we can get even deeper into it then. But yeah, I thought it'd be interesting to sort of give a look behind the curtain into how are we thinking about this as we design it. Okay, so let's check it out. Here we go. Oh no, Zoom needs permission to share my screen. All right, Nico, you're running the show. That's amazing.
No worries. You need to give me back the host.
It's 2022. This is great. How do I do that, my man?
I click on the three dots on my image and then give me back the host.
Incredible stuff. It's just incredible stuff. Make host. Please enjoy. Okay.
All right. We're back right where we left. So,
okay, good. So let's talk about some of the issues with fills today. I think one of the big issues that we discovered when we started doing research was that they're rigid for a number of reasons. Either you're creating these very specific polygons that you have to draw yourself, or you're creating an entire plane and then having to reflow that every single time that you make changes. Both the creation of this, having to manually reflow it, are very rigid and manual processes, and we thought that seemed like a pain point. The next one is that they're not declarative. And what I mean by that is you're not specifying an intent, and they're not designed based on your intent. And other people who come to look at your file, maybe collaborators, teammates, they're not going to understand your intent. Maybe you'll have to write notes and use all these other extra features to describe why it is that you've done what you've done. But it isn't inherently generated based on your intent. And we thought that was an issue as well. That's a principle that we have with Flux. We want things to be intent-based, right? It's parametric design. Ideally, that's the goal. Because that saves busy work, right? So like in general, we just found out there's a lot of busy work here. I mean, that includes like via stitching. Let's say you make a bunch of these fills. Now you gotta go through and stitch them. And just hearing the process from Carrie here, one of our resident product experts, it sounds like he's like, I'm copying vias and I'm just like placing them. Cool. And then if you make a change, now what? You know what? So there's all this and more. We found that there were some problems here. So we went out into the wilds to start finding a solution. And this is just a quick screenshot from FigJam, which is a whiteboarding product from Figma that just got acquired by Adobe today. Congratulations, guys. RIP Figma, though, am I right? Just us showing a little behind the scenes of our thought process, trying to figure out frame by frame, well, how would you create these things? How do you connect to them? What happens if you do this? What happens if you do that? The details of this aren't even really important, just giving you an idea that like, this is sort of how we begin our ideation process. And we arrived at an approach, a set of principles that guided our solution. And first and foremost, we wanted the solution to result in less busy work so that you can move on to the rest of the stuff you care about. We didn't want to just recreate the same feature that required you to move all of your vias manually or draw a polygon or freaking, God, the reflow. I mean, who invented reflow? Am I right? So yeah, we wanted you to have to do less busy work. And then we wanted it to be declarative. You should be able to state your intent and then have the program fulfill your intent. And then that's also helpful because when you're looking back at your old work or a collaborator comes and look at it, it's apparent, how is this being spawned? Why is it being designed in a certain way? And then, of course, we want it to be dynamic, right? So it should just respond automatically to your environment with no extra work from you. Fills are there to support you. They're not there to be the star of the show. They're not there to force you to do a bunch of work around it. You should be doing other exciting work, and fills should be there to help. And then this is this is one that I think could be contentious. So let me know. Get your popcorn. We think that ground fills should be everywhere, and that they should be everywhere by default. Based on our research, it seems that in 99% of cases, the best result is that, and the best modern approach is that ground should be everywhere, and that it's only helpful to be there. And so we thought to ourselves, well, if that's the case, why would we even force people to create these things? If you have told us in your schematic that you're going to be grounding something, like you put a ground in your schematic, great. We're going to create ground fills for you on your layout, and we're going to put them everywhere by default. And we think that that's going to save you a bunch of time, but it is very different. And so I'm going to hand it over now to Nico to walk you through how this actually works. Thank you.
All right, so let's do a quick demo of how ground fills work. So I'm gonna create a new project, and sort of Brooks kind of already introduced some of the or almost all of the key features, and then so let's sort of do a very quick example. I'm gonna first show you a quick example of how it works, how it appears, and then I'm going to move to another sort of more complex example, sort of show how some of the benefits, which are a little bit harder to explain in a simple use case. So in this case, I just basically have a pin or a terminal, and a resistor, my schematic. So if I go to my PCB editor, I see that I just have that those two components, and then if I go to the layer menu here, I'm going to notice a few things. So just to quickly go through, so the most interesting for this case are the top, mid, and bottom copper layers. So these are the layers that have copper on them. So the little eye icon. So basically, let me quickly draw a trace from here to here. So if I click on the eye icon, I hide all the copper or the copper traces that are present in that layer. So every copper, paths, traces, all that. And then if I click on the little sort of drop icon, I enable, or not enable, I show or hide fields. So in this case, I don't have any ground on my schematic, so I don't have any fields. But as soon as I go to my schematic and add a ground symbol or a ground net, I will see that immediately I have my full layout filled with copper. Of course, I can change the shape or size. Let's go for size quickly. Let's go to 20 by 20. And then immediately everything adjusts. So you can see now that we also automatically get the via stitching. So in this case, since the PCB is very small, I only have one via. But going to my object menu here on the left, let's conduct this. So I have a bunch of objects. So I have all my components, then I have all the nets, and I have my ground net. And the ground net contains the fill and all the vias, specifically this one in this case. Now, to configure either the fill or or the VS stitching, I need to use rules. Again, I'm going to send you guys all after specific documentation and videos around how you use rules and how you create stuff based on rules. But just as a quick reminder, rules in Flux not only tell you when something is wrong in the near future, but also can affect directly design. So I can, in this case, create a rule for the stitching density, and then I'm going to add another one for offset. And then just quickly, I'm going to add another one of connected layers. And I'm going to now go through all of them. Now, connected layers is the way that you have to disable fields completely. So if I click on the drop button or icon here, I hide the field or show the field. But even if the field is hidden and I export the Gerber files, I will still have the field because it's just hidden from the UI. It's not gone. If I need to disable the field, what I need to do is basically add a connected layer. For example, just puts it on top. So if I go to the mid layer, you can see that even if I make it visible, there's no copper field. Or I can add nothing to the connected layer. And that means that the field is gone from all the layers. If I disable this rule, the field is automatically back in every layer. So in the mid layer, top, etc. Now, the stitching density is basically how separated do I want the vias that are part of the via stitching. So I can do a 5 millimeter density, and then I have vias separated every 5 millimeters. So this is what we call a vector rule, which means that if I can specify different values for the x-axis and the y-axis. So for example, I can do 5 and 10 millimeters. So you can see that in the x-axis, I have 5, and in the y, 10. So basically, since from here to here, I only have 5 millimeters, I can only fit one row of vias. And then basically the offset is from 0. So this is 0, 0 in the design. I can move the whole via set by X amount to the, like in the x-axis, or by X amount or Y amount in the y-axis. So for example, I can do 1 millimeter and 2 millimeters. And that moves the whole set 1 millimeter to the right and 2 millimeters up. And what that means is that now I have just barely enough space to fit 2 rows. And this is basically to allow you to configure this, because again, this is going to be more clear in the next example. Or the use case is going to be more clear. It allows you to configure exactly how you want your vias to appear in the design. So if you need vias in a specific place, you can modify the offset to have vias in that specific place, or you can modify the density depending on what your layout requires. Density usually depends on like what type of signals, like the frequency of those signals. So the fastest the signals you have, usually the closer you need each via to each other, so that whatever resonates is higher up in the frequency range.
And also just chime in your demo, nothing's stopping you from making your own via in any particular spot that you feel like, wow, I need a via like right there. Great, you can do that, right? The automatic via stitching is just here to sort of help capture, again, like 99% of what you're going to need to do for stitching.
Yeah, exactly. And that's what's going to be my next point. So a kind of a good design process. So this is kind of what Flux offers by default. Now, a good design process kind of dictates that whenever you have a trace that goes to, for example, let's say that I now have a trace that goes through the bottom copper, and then goes back to top. Ideally, you always want a via right next to whenever you're changing layers. So in this case, it will be a good idea to just add a via right next to it. So you have the default via stitching that kind of makes it good for most of your design, but you also need to be thoughtful depending on the signals and the signals and the frequency of the signals that your design is using, that you might need to add extra vias in specific places. Or for example, if you have islands of copper, you might want to add a via to that place to specifically connect it to ground, which is going to be clearer on some other design. What?
Oh no.
There we go.
Oh yeah.
All right. So this is basically, this is the same project that I shown on the presentation. And in this case, so you can see that copper makes a lot more sense. And there's two things that I wanted to mention. One is, so in this case, you have this copper. So let's say that well, this is actually connected, but let me quickly just move this around just for the example. So you see in this part of the circuit that there's this island of copper that is not connected to the main ground, and also due to where the stitching vias are placed, this ground is not connected to the ground plane in the bottom layer. So this is exactly where it makes sense, as Bruce was saying, you can either add your own. You can either add your own via right there, and then connect this via to ground, or you can. The other option is modifying your. So who's?
Someone's unmuted.
Yeah, I didn't pick up who was. All right, fine. Or you can modify the offset of your vias, and then make them land exactly where you need. In many cases, this is going to be kind of a tricky approach. The best way is going specifically to that island and then placing the via to make sure that that is connected to wherever it needs to be connected. Because in most cases, except for very, very specific cases, in most cases, you don't want here. So I basically put when I move the stitching via, I just automatically got a via placed.
Correct me if I'm wrong, though. Like our roadmap includes the ability to stitch islands like that automatically.
Yes,
so
that was what I was gonna say.
Yeah, this represents a bunch of work that we're trying to put out there, but there is more to do. We just wanted to put this in your hands as quickly as possible.
Mm-hmm.
But yeah, we will be stitching those islands for you eventually.
Yeah, exactly. And there's two things that we're having a roadmap. One is that you kind of either remove them all together, or you can automatically stitch them. Depending on the size, you might want to do one or the other. So for example, if the island was super small like this, in that case, you might or like this, you might want it gone. So that we're gonna remove it. Or if it's big, we might want to automatically connect it. So that's it for what we had in terms of demos. We can.
Oh wait, I think there's maybe one other important detail here that might also be controversial. I'm so curious to get your guys' feedback right after this. Would you please hide your fills in this project, Nico? So you
Yep.
got to dismiss the part updates there. And then here we go. We're going to go
All of
ahead
them.
and hide all of them. There we go. There's just 2 layers, so that's great. This is what you will see in your projects, because the other decision we made is that we want to hide fills by default. Constantine, you are unmuted, my man. We want to hide fills by default, ground fills, because they're obviously incredibly intrusive. They get in your way. You can't see the bottom, or any mid layers are going to get in the way. And so they're going to be there on every project that's grounded, and everything's going to be grounded and connected automatically, but you're not going to have to worry about them at all. And so they'll be invisible, yet ever present. That's the other detail here. Thanks. Okay. Is that the whole demo?
Cool.
Nico?
That is the whole demo.
Right.
Gonna leave this here.
So
you want
what's
to
next?
open
It's
for
Q&A, right? Yeah.
questions? Yep. So we're gonna open for questions. Again, questions like goes anything from the demo itself, how the VS teaching works, how does the ground field work, or if you are curious about why we did something one way or another. Like you have the designers here, the PCB experts, you have developers that work on this. So
yeah, and feel free to use the chat if you don't want to unmute. And also feel free to be spicy. We know we're taking a stand here. We know we've made some decisions. I want to know what you think. All right, bring it on, guys. What do we got?
Hey, this is Andrew Oldenburg. I have a question on the spacings. Or maybe this is, right now it's like, it looks like it's uniform across the board. Do you foresee like having the ability to define different areas with different via spacings?
Sorry, you mean about like spacing around, because there's something that I forgot to mention. So you have the spacing that from the trace to the ground field. So you can define different spaces for each trace, net, pad, or whatever, and then the spacing, and you can do so with rules. Actually, let me.
Oh wait. Andrew, which spacing are we talking about?
Yeah, we're talking about like spacing between tracks and ground, or the field, or spacing between.
It's the via space, the ground fill.
This is extremely crazy.
I'm sorry to interrupt you, Andrew.
Yeah.
Hey, whoever's the host,
continue
please
living
mute
on.
Constantine. I think that's you, Nico.
Oh my God, I'm
Okay.
sorry.
That's all right, bud. Okay, Andrew, one more time.
It's the ground via spacing. That's what I was talking about. The automatic vias that are placed. I was just wondering if you're going to have the ability to have for the ground vias that fill in the for the ground fill. It's that spacing that I'm talking about.
Is that like kind of having different zones where there would be different spacing? Is that sort of what you have in mind?
Exactly. Yeah. So different zones
That's
would have
exactly
different
what
offsets,
I'm thinking about. Yeah.
different densities. Yeah.
Care of adding a layer of abstraction between all these different hardware components. You do not
Adam, now it's Adam is multitasking. He's in multiple streams at once. Adam, we're gonna need you to mute as well. Dude, Andrew, we'll look into this. But I'd love to know just off the cuff what those zones would be used for. What's the intent sort of behind defining these zones?
So if I had a board that was just kind of a general, like say microprocessor kind of stuff on one portion of the board, but then one portion was more RF, where I want more RF specific, where now I want a very tighter ground fill on the or via spacing on the ground. That's kind of the idea. I've done this on my cards already, so in the past. I mean, that's as soon as I saw that's one of the things that came up in my mind.
Yeah, that's great. We'll totally look into that. Appreciate the recommendation, Andrew.
I love that idea. And I also think that one of the dream features for this type of application is auto stitch vias. Like, why should I even have to define the proper spacing between the vias? It should just know based on the ground density and the current density and whatever, where is an appropriate place to add vias. And it should stitch all my islands for me. I shouldn't have to worry about the spacing at all. And it should, you know, instead of me defining those regions, it should be able to do that for me. So I think that's the very long-term feature of all of this.
Oh no, yeah, that'd be great, right? I mean, yeah, it gets kind of tedious because when you have to go through and kind of look at the card, at kind of like right now at the screen, you're kind of zoomed in and you have to look around and say, oh, I need some vias here, I need vias there, and you have to move across the card and do that. And it just takes up a lot of time.
Totally.
And just another follow-up question to it's a very interesting point. So just pulling from your example, so in the case, for example, when you have RF, like an RF portion of your board, do you typically use the same ground, like name the same ground, or you kind of like use sort of like a different ground, you name the ground differently? Because one option could be that you can have different properties if you have different traces or different nets. So if you have different ground, that could be treated differently. So I was curious, like what do you typically do? Do you have the grounds named differently and then you connect them somehow, or you just have one single ground and you treat differently depending on where it's placed?
Yeah, you're delving into things that people have their personal opinions on.
Yeah, that's why I was asking yourself.
Yeah, no, what I tend to do is I like to have one ground and I make sure everything's tied to it. No, I mean, I've split grounds before on my designs, right? You know, basically, like you said, you have like two different symbols on the schematic. I've done that, and the potential to cause problems. I mean, like you're talking about your fields and stuff like this, and with the signals, the potential to cause problems between ground splits is huge, right? And and it's I always tell my newer engineers, just do one big ground. You know, just tie the whole thing. And if you want to try to do something like that, you need to have a really good case and good reason to kind of split a ground.
That's great. And sorry, go ahead.
I'm done.
Okay, great. Yeah, I want to leave room for more questions here, and we got one in the comments. Randy says, is the ground layer typically on the component side? And would there be a corresponding VCC layer on a 4-layer board, for example? So Randy, in this example, you know, Nico, you can flip the board and show that ground is currently everywhere. Ground is even on the bottom layer. And if you, yeah, there we go. And if you had mid layers on this board, if it was a 4-layer board, currently ground would also be on each of the mid layers. And that's sort of why we have internally just been calling the project Ground Everywhere, because that's it, man. It's everywhere. Now, there is a future for this project that, of course, includes power. Right now, fills are only for ground, but of course, you're going to probably want a power plane. And so we will be implementing a way for, depending for net by net, you know, you'll be able to go to a net and say, this net, I want it to have a fill and I want it to be on this layer. So again, it's intent based, right? So you tell the net to generate the fill and you tell the fill which layer to be on. And in that way, you can create a power plane on an internal layer only, and that will displace the ground fill. Ground will get out of the way for your power. I hope that answers your question.
Hi, Nick.
Hello.
Hello. So I have a question related to this ground. So can you zoom on to this C4 that you have in your design?
Yep.
And can you please show me the top layer? Yes, this one. Yeah. Okay, so I see one of the pin of this C4 is grounded, right? So I have had some issues with my design. Basically, if some hobby project and I don't see any thermal reliefs and copper spokes to this pin. So basically, it's a huge big plane, and it has a big thermal mass. So if I do as a hobby project, if I do soldering, so it's a big pain. So do you have such plane for this?
So currently we don't have thermal relief, but yeah, it is in a roadmap. So just for everybody to understand the question, to repeat it. So when you have such a big chunk of solder directly connected to a pad, and you want to solder something specifically, or more especially if you want to solder it manually, you need a lot of heat to heat in this pad enough so that the solder melts. So you need thermal relief in this case. So yeah, the answer is we don't currently have thermal relief, but we will have it in the future. Again, as Flux was saying, this is kind of the very first iteration. We want to put it out there for you guys to try and hear exactly this feedback. This is actually what we're here for. I don't know if that answered your question.
We have thought deeply about thermal reliefs, by the way. We have a whole plan for how to deal with thermal reliefs, how to configure thermal reliefs, etc. So the plan is there. But yeah, like Nico said, we're just trying to get this into your hands as quickly as possible.
Yeah, thank you so much.
Yeah, of course.
No worries.
What other questions do folks have? And again, you can use the chat if you want to. Oh, Randy, again, what's up, man, in the chat? Does Flux provide an option for hatched ground fills? Anybody know the answer to that?
Yeah, I know that Kerry loves to talk about hatched ground fields, so I'm gonna put him in the spot. I can answer the question, but he loves that.
Yeah, hatched ground fills, man. Hatched ground fills are important in a couple of different circumstances. I won't take up too much of your time because I had a session last week where I talked about it, I think for almost 30 minutes straight, which was fun, but I don't know how fun it was for the people listening. Yeah, so instead of doing a completely solid ground fill like this is, you could do different hatch patterns. Usually how I've seen it is you define the percentage of copper that you want, or the percentage of void. And so you do something like, I have 60% copper coverage, I have 70% copper coverage, something like that. This is a really useful way to tune your impedance if you have a board that is a really tight stack up. Like if you have a flex circuit where the layers are really close together, sometimes it's really hard to hit 50 ohm or 90 ohm impedance because your layers are very close together. You'd have maybe like 10 times closer together than a normal PCB. And that's sort of cool. Yeah, that's sort of what a hatch looks like. And so two ways to tune impedance: you can move your ground flood closer or further away. If you don't have that option, you can tune the amount of copper that's present. And so if you have 30% copper instead of 100% copper, that changes your impedance. It's a pretty good way to get you that impedance that you want within your design constraints. I don't know that it's usually very necessary on rigid PCBs, but one of the other cases that I've seen it is also on flexible circuits. When you have a solid ground pour, it's very hard to maintain the flexibility of the circuit because there's so much copper, and copper is very rigid. If you do the hatch ground pattern on a flex, as Nico's showing, you can maintain the flexibility of that circuit. And so that's one way that you can hit your mechanical constraints. As for the Flux instantiation of that, we are not able to do that right now, but we want to, and we will definitely eventually support that.
Yeah, especially if Kerry sticks around, because he won't stop talking about it. Well, you can guarantee that we'll have it, if only to shut him up. I love him. I'm just kidding. I'm just kidding.
That's the only reason they make any features.
He's half right. All right, I hope that answers your question, Randy. What else do we got from the audience? Is there stuff that you I'm just curious, is there stuff that seems nice? We have talked about some pretty different approaches here. Maybe you like some of it. That'd be nice to know. It'd also be nice to know if you don't. Looking at you, Harold. I love the avatar you have there. It's very approachable. I'd love to know what you think. Or Bill. Or even Mr. Mo. I'm going to take your silence as just thunderous applause. You know, just the most excited silence. You're riveted. White knuckles just on the desk in excitement. You can't reach the unmute button.
So here's an important question. If we don't want ground fills, I know that it's nice to have them everywhere, but say there's a situation where you don't want them, how do you turn them off?
Trying to find an unmute button. So the way to do that, I think I showed you on the first. I thought I should. Maybe I forgot. So basically, the way to do that is, so if you go to your net, in this case where the field is connected to the ground, you can add another rule. It's called connected layers. And then basically, if you say that you don't want, so here you can basically select what layers you want ground fields to be connected to. So you can just say top, you can say bottom, or you can say none. If you say none, then all fields will be disabled. So here I'm going to reiterate this point. There's fields visibility and fields enabled or enableness, or enabled or disabled. So with the layer menu here, you make them visible or invisible. With the connected layers rule, you enable them or disable them. So if I put it on the top layer in this case, so the field is going to be enabled. I can hide it with the drop button, but if I export the Gerber files will contain the ground field. Does that answer your question, Corey?
Cool. Yep, that covers it.
What if you had an area, just, I can't think of a specific situation right now, but let's say the top left 1/4 of the board, you don't want to fill it all. Is there a way to say this quarter, no fill? So if I want to take the top left quarter and not have a fill?
I think to answer that question, we would need a specific scenario. Most of the scenarios that I've encountered where that is the case, it's because you want to keep something away from a particular component for interference purposes. And so the way that we're thinking about that is you would tell that component, hey, you component, please have a keep out that spans multiple layers or all layers. You can define which layers it is. And then that keep out would then be an intent, which would keep the copper out. But again, it's intent based. It's not just like a polygon, like, whoa, I'm going to draw a star in the upper right, and then it won't, and then that'll.
Yeah, I couldn't think of something right offhand, but that makes sense. If I didn't want any fill around, say the top left positive pad, I could just increase the no fill around it, and that way it wouldn't fill, and I can push it away as much as I want.
Yeah.
Yeah, I mean, one example, a good example is when you put a module that has an antenna on it. The antenna cannot have ground or copper below or above where the antenna is placed most of the times. So in that case, it's as Bruce was saying, the component has a specific requirement. So in the component, you will set up the keepout, which is intent-based. You're actively saying this component needs to have a keepout in this place.
That makes sense.
And that translates everywhere.
Yeah, antenna was perfect. That's something I was trying to think of something that makes good sense on an antenna, because otherwise you absorb all your signal with all the ground around it. It's not an antenna anymore.
Yep, exactly.
We got a question in chat here from Anand. Yep. What's up, man? He says we need to think about multiple pores adjacent to each other and providing priority. You're absolutely right, Anand, and we have, but we're not there yet. Once we offer you the ability to create power, basically fills on any other net besides ground, that means you're going to be able to specify which layers those get generated on. I mean, imagine you tell 2 nets to be on mid layer 1 same time. How are we going to resolve that? We have some ideas. We'll tell you more when we get there, but we're absolutely thinking about it. Thanks for watching out for us there. And we got another one here in the chat from Adam. Joined late, apologize, that's okay. A quick, why use this instead of Altium before? Oh man, you missed it, man. You missed the good stuff. It'll be in the recording, but hey, TLDW. Because it's no man, it's all in the recording, you know. It's automatic, it's faster, there's less busy work. We're doing all sorts of things for you that you're going to do anyway. We generate it for you already on the fly, and then we hide it. We do stitching for you. It's all intent based. So again, it's easy for you to just say what you want, have it happen. There's no busy work like having to reflow, etc., etc. But it's all there in the recording, Adam. And by the way, we're at time, right, guys? I think we're 3 over here. I'm happy to stick around and keep answering questions. But I think we should just acknowledge for folks that are just joining at their lunch hour. You know, thank you for coming, right? And spending some time with us. You're free to go. No need to stick around. But for those who want to stay, by all means, please, we'll be here. Does that sound right, Nico?
Yep, exactly. And then I'm gonna email you, well, you and everybody that joined the recording at some point tomorrow. When I had some that downloaded and then I did a little bit. So I'm gonna make sure that you have the recording. So the recording of this session, along with all the other recordings of other topics that we've covered and we've said. If you want to dig deeper, you're gonna have all the videos for all the different topics. So I'm gonna make sure to send the email out tomorrow at some point.
That's great. And a couple other notes, maybe just before you go. In the chat, there is a link to our Slack. If you are not in it, please join it. Come talk to us. Tell us what you think. And then if you want to try this, if I'm not mistaken, it's live right now in Flux. Go to flux.ai. Wow, it's in your projects. It's inside your designs, right? So go try it and tell us what you think.
Thanks, guys.
Thanks, Bill.
Thank you.
Yeah, appreciate everybody coming. Okay, if there are any more questions, we're still here. Hit us with it. Thoughts, comments, approval, disapproval.
I think Anand has another one in the chat.
Okay. Yeah, Anand says, I almost wish Flux.ai will just auto place and route. Rest of things, already existing tools in the market already does a good job. Yeah, man. Wow, Anand. Have you been reading a roadmap? That's wild, man. Good thinking. Yeah, let's do it, guys. Anand, it's coming soon, okay? Just sit tight. It's a long road, but that's absolutely where we're going.
Yeah, I mean, we need to build all the foundations together eventually, and this is exactly what we're doing here. So building one step at a time to get to that point.
That's right. And Adam says, designed by AI in there too. Well, we got to earn that AI in our web address, right? Somehow. So stick with it. We'll get there. We got to cover some of the basics first, and then we're going to start bringing in some of that crazy special sauce with the AI. You'll see, though. You'll see. It's going to be great. And thanks, Anand, for saying keep rocking. We will, man. It's great to have you here supporting us. We're happy to support you. You're welcome, Adam. Adam says, excellent. Thank you. Yeah, anybody else? Questions, comments? Toss them in the chat.
I have more practical questions. How far is this keepout zone for footprints in pipeline? I mean, when can we expect this keepout regions for Copperfield?
Oh, like I was describing, where you could tell apart, hey, have a keep out, have it apply to these layers, that sort of thing. Well, if enough of you submit that in Canny a lot sooner, okay? So rally your troops, my man, and get going.
Okay.
It's not, we haven't prioritized that just yet. Yeah.
Okay, I just want to ask if this feature is priority or not in your vision, or I don't know.
Yeah, I mean, we've got Matthias on the call, right, Mati? Do you want to chime in there, bud? It's okay.
Hi there.
Hey.
Remind me the specific feature wish here.
The wish is, as described, a keepout that belongs to a part. So the part would say to all fills, hey, in this amount of space and on these layers, stay away from me, please.
Yeah, good question. I mean, look, we've started doing quarterly planning. This quarter's coming to an end, so that means we've started planning for next quarter. We haven't made any decisions yet. We're like right now, actually, Lance is working on researching all these needs. So definitely, like Brooke said, put them in Canny, and then we can look at that. It's really simple how we do this. We look at all the things people want, and then we just prioritize and figure out which of these can we deliver, in the next quarter, and those are the ones we grab. So I also think in that sense, right, like Brooke said, the more supporters you can gather for that feature request, and the more likely it is we can squeeze it in. Maybe not a satisfying answer, but the truth.
Yeah, it's thank you for answer, Matthias.
Yeah, we definitely want to do it. We definitely want to do it. It's just a matter of making it a priority.
Yeah, exactly. Right, that's important. We definitely want to do it. It's just a matter of when.
Thanks for the question, Basil.
I don't know what else, because it's in my priorities. This is important feature, but I don't know what else. What next feature we will see? Maybe I will like it even more, but I don't know. I mean, feature that you planned.
Yeah, and I'm gonna do a shameless plug here. So in our Slack community, Slack channels, we usually share what we're working on. We share previews of what's coming. So if you want to join the Slack community, we have a bunch of channels for getting design reviews, asking questions, requesting parts, just talking, and then also sort of kind of learning the news and the next features before anybody else does. So that's a good reason why to join the Slack community.
Hey, we haven't heard from Mr. Mo. Harold, we haven't heard from you, man. Curious what you guys think. You've stuck around this long. Clearly, there's something interesting going on for you, right? I mean, unless you're AFK, then Harold, get back here.
Yeah, or the Zoom got stuck.
Yeah. But yeah, I would love to know what you guys think there. And Mr. Mo. Mr. Mo, you've been using Flux for a long time, so yeah, really curious.
Oh, guys, sorry, I turned off my microphone.
It's all good.
Can you repeat, please?
Open-ended request for feedback, Mr. Mo. What did you think of what you saw here today? You've been using Flux for a long time.
Yeah, I am using Flux for a long time. I was very waiting for this feature. This awesome feature. I think in future we can improve it. We should to add some another tool like couple fields, but something like polygons, because sometimes I need create a region, couple region for some nets like VCC or something like that.
I'm so glad you brought that up. We haven't talked about that yet, but for those of you who are still on the call, you might be interested to know that we see, look at that. There is a future of fills here, and we see three main use cases. And the first one we're already solving, ground. The next one is obviously, well, if we already have the feature for ground, it's basically the same thing for any other net, like a power net, right? But the third one is particularly interesting, and that's high current lanes. That's what you're talking about, I think. You're talking about being able to draw a trace. It's a high power trace, but it's gonna have to have some special shapes. And we have an interesting approach for this, where it would be a different way for a trace to work, the stroke width of that trace in particular. would act more like a fill. And so you would draw like the bones of what you want that trace to be, and then the width would sort of flow a little bit around those bones, trying to do its best to maintain the size you want without necking in, and arriving at the destination that you want.
Okay, got it. Makes sense.
Yeah. Yeah, and again, this is one of those things, now that this is out there, put that feedback in Canny, because we need to prioritize this feature. We know we want to do it. It's just a matter of when. But I'm really glad you're thinking about that. I've seen specifically how you are using traces in Flux already to create the kind of high energy traces that you're looking for. It's a pretty cool hack you got there, but we want to actually solve it for you.